stitches, okay? I say you're too young to. It does not feel good though.
Here's how to get stitches. I'll try that one.
Okay. Ready?
Whoa.
However, hold on. Press and hold.
You want to see something?
Whoa.
Well,
Ready?
when we first noticed this, when
So this is the
science
best
teacher
because it's also
saw this in front of
lightweight,
this class,
but it also
people
has a
weren't
large
thinking
surface
so much
area.
about,
So it's like a
or
plastic tube. Obviously, a metal tube is more durable than a plastic tube is lighter. So that can affect decisions on how much water you put in your pipe, for example. The plastic tube is bending, pinkies are light. So you put metal pipes underground and use plastic tubes above them.
the batteries were very scary.
Cool.
So certain materials do play. Okay, we'll have to stop this for a second because I need to. So one thing that electricity does do, especially when you have this much electricity, is
And
heat.
so if there was a cheaper way to
So,
separate it
so that what happens is when this gets too hot,
in fact, for the first time
this
in
actually has
United
warning
Nations
safety
states,
goggles recommended for use. Yeah,
research
I wear
against
glasses,
this
so
way.
trust me, these things have saved my eyes
Because you
more
see,
than I care
whenever we
about.
have moving charge,
Wow.
Mainly just because of wind
we have a
debris.
magnetic
The
Yeah.
last thing you want is something.
Yes.
Hardly fit this one.
In
It
fact,
starts to get hot, and he said, listen to him.
try this one.
Let them cool it down.
We'll try one more. You ready? Careful.
Whoa.
Sorry. Oh, it's okay.
All right.
No, it's fine. So now, the reason this gets hot is because we have a big coil of wire here, but when you have electricity move, sometimes energy isn't always pure. Nothing is truly pure in this world. We lose. When you kick a ball,
So in this case,
your foot hurts a little. If you ever kick a ball really hard, how does your foot?
we'll push electric charge through the
Kind of
wire
hurts,
to it.
especially if you kick it really hard, and especially if the ball is heavy.
Yeah. Here, stand up.
Yeah. I was gonna say,
Yep.
okay?
So he's talking about there's no pure energy.
See?
That magnet got stuck.
And it did get stuck. In fact,
Like a good example is like the LED lights, right? I mean, compared to
LED lights are
compared
more
to
energy efficient. So
yeah.
when you say efficiency, what I mean is
to the hot lights.
how, yeah. So how much energy goes from one thing to another? If you notice, this light bulb, how bright is it? Not very bright, but it gets brighter the closer to the source. This is what I mean by efficiency. As it gets closer to the main source, the electric forces, the magnetic fields get closer.
Yeah.
Right. In fact, I can also show this. The magnetic forces get weaker with distance. So, is this vibrating much?
No. So are the forces on other objects. But if you observe
I can tell
the
you it's
same
still
thing,
vibrating, but you're not
whether
hearing it.
moving around,
Oh.
You hear it?
the
Yep.
only way you could just realize
These forces get weaker with distance. So we can lose efficiency or gain efficiency by putting things certain distances away from each other. Sometimes when you rub your hands together, they get hot,
and
right?
all those windows you see out
You
in the
feel
desert,
warm.
you see
That's
those?
friction.
Those big
You're making
propellers,
heat. That's what they use a match. Matches make a chemical
in all the
reaction based on
hydroelectric
friction
jams, falling
to
water
start a fire,
going
and then you can
through
use
the
that to light a
generators,
big fire
reflected
and get more
some
energy that way.
magnets to give us electricity.
Energy, some energy is lost. It takes energy. It's not that energy is never created nor destroyed. It just changes forms. And if we don't want it, and when it changes forms, can depend on if we want it as good or bad.
So we generate all of our
Good or bad energy.
Yeah, Alex has a whole bunch of little hand crank generators over there.
Explosions.
And if
Right
you
over
look at them,
here
they look like
is a good
motors.
example of energy.
That's because
Ah.
a motor is the same thing as a generator, just depending on how we use it. If you send electricity
Like right here.
into a little wire here, a
ahead and turn
magnet, it's going to
Go over there.
Go ahead and turn the crank.
But if
Go ahead and turn
instead
the crank.
you put a little wire near a magnet, out there,
It takes energy to make something. It takes energy to make
the motor
these
will
moves.
use this as a generator.
I think this light bulb just might be dead.
And this is a rather
The light bulb's gone. They're filament bulbs that are very
By
tiny.
putting a little box inside here,
Go ahead and turn it.
and inside the box is
Here's one.
and it's got a magnetic coating on it. And right here, at the very
Try it.
tip, is a tiny sheet of coil of wire. And as the magnet moves past that coil of wire, just like what I did here,
Or the fan.
that'll produce electricity. And as the magnetism changes along that tape, the currents that are produced by
I
the
think I know why.
Yeah. He's cooling off.
I have to make some repairs.
and you know how
Okay.
speakers work. So this can play music, but it can also
I know. Isn't that cool?
just like the motor